Hello, in this video I'm going to be upgrading the Y-axis of the Gibson Mini. As you've probably known if you've watched my other videos, the Y-axis was having a tremendous amount of trouble due to the flexibility of the PETG it was made out of, as well as the infill was not substantial enough to keep it from bending. In order to solve this problem, I was able to use a piece of steel, a steel plate, to reconstruct the axes entirely. Here you'll see me do that, using a vast variety of tools at my disposal, as well as my CADing skills. Enjoy. So as you can see, I've already gone ahead and cut out the two steel plates that I need from a piece of stock, I guess you'd call it. And this piece I've already filed down the edges, or it was cut with an angle grinder. And I've also already drilled the holes in the four corners. Now for this piece, I've already gone ahead and filed and chamfered the edges. And now all I need to do is drill the holes. I've already marked where those are going to go. Now I just need to punch them and be on my way. Now while he's doing that, I think it would be quite entertaining if I told some jokes, wouldn't you? Oh well, you don't have a choice. Here goes. The oldest computer can be traced back to Adam and Eve. Surprise! It was an apple, but with extremely limited memory, just one byte. Then everything crashed. So while I was drilling these holes out, I noticed that this side that has the single bearing, well, these holes aren't directly perpendicular, or let's say parallel with each other to make a square. It's kind of a rhombus, and it's leaning this way, if you can tell. But I hope that I made the holes big enough so that when I put these on here with the zip ties, that it'll be able to compensate for it. So it seems there's a problem with this steel sheet in that when you put it on the print bed and it's moving back and forth, that this top edge hits the motor, the Yaxis motor. So I've gone ahead and marked out the part I need to get rid of so it doesn't hit the motor any longer, and I'm going to take an angle grinder and try and cut it out. I might just I'll start with a hacksaw, see how that goes. Well, it's me from the future here in editing, and I can tell you this was hard. Cutting through the steel with a dull hacksaw is hard work. Especially when you attempt to cut the steel at the steep angles I did. So, on the undercarriage, the first one, it was made of plastic, as you can see. It was 3D printed, and it was this special piece that made it so that the timing belt hooked into it. As you can see, there's a dovetail right there, because it was printed in two pieces. This top portion was printed separate. So now I need to find a way. So now I'm going to go onto the 3D model, slice this off, so I have the bottom half of the dovetail and the top half of the dovetail. Raise the dovetail up about 1.5 millimeters, and then 3D print those so that I can then drill holes into here where I've marked where it goes, and then zip tie it down, and then put the dovetail in, and it should be exactly in the same place as this was. I'm also going to do that same thing with this, the arm that triggers the end stop. I've marked where it goes as well. So yeah, it's a lot of progress. The result, this is what is going to hold the bearing against the steel plate. So the bearing is going to go into this pocket, and then I'm going to have zip ties wrapping around the bearing and the steel plate is going to have holes drilled in it where these zip ties will be. So I'll need to go ahead and print 3 of those out now. As you can see, I've gone ahead and printed out the new timing belt holder, and it's 2 pieces slot together like that with a dovetail. The top piece has the 2 loops for the belt. This bottom piece had to be specially designed so that to accept zip ties and allow this top portion to slide in, and for the zip ties to not interfere with that. So I've also gone ahead and marked out and drilled holes that match up with the holes in here, and now I'm going to zip tie it together like that. So it seems that finally, after a half-hour fiddling with this thing, I finally got this new Yaxis undercarriage on there. As you can see, it's zip tied on, and that was what made it take so long, was all the zip ties and trying to line them up with the holes and trying to line the bearings up with where the zip ties were supposed to go. But finally, it's on. And as you can see, it hits the limit switch right there, and nothing gets in the way. Comes all the way forward. It works fantastically. Now all I need to do is attach the second part of the, it's the top part of the dovetail, so I can connect the belts to this new Yaxis. After a bit more struggle, I finally managed to get the top bed portion on. I did have to use bulldog clips to secure the glass plate onto it. Now it's just a matter of leveling the bed to see if this new Y carriage improves the print quality and gets rid of those weird ripples I was having. I also had to upgrade the springs to something quite a bit beefier, as it's now holding up an entire steel plate instead of just the this old plastic bed. As you can see, this one can flex quite a bit. So now the question is whether all that hard work actually changed anything. Well, the answer? It's complicated. I did print a vase with the new steel bed and undercarriage, and as you can see, there is still a substantial amount of waviness in the print. Now, I marked out the Y and X axes because it was printed like that if you were facing towards the printer. And I noticed that the side closest to where the Z axis is, you can't see the rippliness quite so defined as you can on the side opposite of where the Z-axis actually is. And so, in conclusion, yes, this upgrade did increase the relative stability of the bed as well as making it less flexible. But it seems that the next upgrade that needs to be done is a redesign to use 2 Z-axis motors and 2 lead screws in order to lift the X-axis up on both sides and be supported on both sides. It seems that the next video will be me going throughout that process. I hope you enjoyed this video. Remember to subscribe and hit that bell notification if you want to see more of this ongoing project with the Gibson Mini.